All right, well, good morning, everyone. I'm Rob Atkinson, president of ITIF, and I want to welcome you to this event on Advanced Manufacturing Partnership Initiative that the White House has led now for a number of years. And I'll always remember maybe 4 or 5 years ago when we, as an institution, got into manufacturing innovation in a pretty serious way. We held our first event, which I think was based on a report we did called The Case for a National Manufacturing Strategy. And somebody came up to me and asked me, said, Rob, I don't really get why you guys are doing manufacturing. I thought you were a think tank that focused on innovation, which was a striking comment to me of either how we had not conveyed that actually most manufacturing is actually pretty innovative, or the fact that in Washington there's still this sort of view that manufacturing is old economy and only software and biotech. But even actually, biotech actually is manufacturing. IT hardware is manufacturing. So in that sense, I think we've made, as a country, we've made a lot of intellectual progress in the last 4 years, and in large part through the leadership of what the Obama administration is doing, and Jason Miller's work, who I'll introduce in a moment. The administration launched the National Network of Manufacturing Innovation, the NNMI. They've established 5. Is that right now, Jason? Pretty good. 5.
On our way towards 8.
Yeah, and also have worked with Congress on a bill called RAMI, Renewing America's Manufacturing Initiative, which we've helped with as well. So there's certainly a lot of action going on, and then the other component of that is this initiative, this Advanced Manufacturing Partnership the administration put together with leading private sector and university leaders in this space to really get a better handle on where we are as a country and what we need to go forward with in terms of policy. So this is the focus of the panel today. We've got 3 great speakers. I'll just introduce them in order. Jason Miller, who's the Deputy Director of the National Economic Council, the NEC. Prior to that, he was really leading manufacturing policy in the White House with special assistant to the president for that area, and has been supporting the administration's advanced manufacturing policy efforts. Prior to coming to the administration, he was a consultant with the Boston Consulting Group and Americon Associates. Ravi Shankar is the Global Business Advisor of Dow Chemical. He co-led the Technology Working Group on Advanced Manufacturing Partnership 2.0, or AMP. He also is the Global Business Advisor to Dow Chemical. He's been in a number of different roles at Dow, including the CEO of Dow CoCam, which is a team that had worked on advanced batteries. He was also Corporate Director of Ventures and Business Development for Dow. He's been with Dow since 1991, and he holds a PhD in Mechanical Engineering from University of Delaware. And last, on my far left, Kristen Van Vliet is the Associate Professor of Materials Science and Engineering at MIT, and also is co-led the Technology Working Group here. She joined the faculty of MIT Department of Materials Science and Engineering in 2004. She leads the Laboratory for Material Chemomechanics, also was in the Department of Biomedical Engineering, and is the director of the Nanomechanical Technology was the director of the Nanomechanical Technology Laboratory. She also co-directs MIT's Biomedical Engineering minor program and leads the Singapore MIT Alliance in Research and Technology on Biosystems and Micromechanics. So certainly a distinguished and expert panel, and I think we'll kick it off with Jason.
Great. Thanks, Rob. Thanks, everybody. I just want to, again, ITIF's been a fantastic partner over the last several years on this topic broadly. Rob's always personally a thought partner, and whenever you need 50 new ideas, Rob is the right person to call. Let me just make a few points. One, I think that this effort really would not have been successful without choosing the right leadership from academia and the private sector. And I think Dow and MIT were definitely the right organizations with the right people. So a huge thank you to Kristen, Ravi, the whole Dow and MIT teams, Bill, Phil, and many people that aren't here, and of course Andrew Liveris, Raphael Reif, and Susan Hockfield, who I think together have made enormous strides here. Let me talk a bit about some of the things that I think AMP has achieved broadly before we get into some of the specifics. One, and Rob mentioned this, I think over the last 3 or 4 years we've seen a pretty dramatic shift in the dialogue on manufacturing, in no small part because of the Advanced Manufacturing Partnership. The disagreement at the beginning, there was a why are we talking about manufacturing? This doesn't matter. Stop bothering us. That is not the debate that is happening today. The debate that is happening today is, well, are you sure that these are good paying jobs? Is it really coming back? Can we be competitive here? That's a very different set of questions than does it matter or not. And I think the Advanced Manufacturing Partnership has played a central role in shifting that debate, in putting innovation at the center of why manufacturing is important to the U.S. economy. The second is, I think, along with changing the national debate, it has influenced the way that the federal government acts. To some extent Congress, but definitely the executive branch. If you look across the agencies, many of the agencies reflected that general view on manufacturing at the beginning of the administration, and I think, and Ravi and Kristen can probably speak to this in more granularity, when you interact with the agencies, with leaders, both political and career leaders across the agencies, there's a very different perspective, and there's a very serious focus on steps that we can take to spur manufacturing, and that's across the government: commerce, defense, energy, NSF, NASA, labor, education, small business administration. And you really, while coordination is always challenging, having all of those areas pushing forward has been enormously helpful. Third, along with that shift in perspective, we've seen action, and the second version of AMP was very focused on implementation of action. We'll talk a little bit more about that. But the process was not linear in the sense that we spend 12 months or 18 months coming up with what we're going to do, and then we spend a couple of months figuring out how we're going to do it, and then we start acting. We were acting simultaneously from the learnings that were being generated with the Advanced Manufacturing Partnership over time. Just as an example, in the first iteration of AMP, we launched the National Network of Manufacturing Innovation in the middle of the AMP process, and it was very clear that it was one of the ideas that was coming out. So we were building it as we were flying the plane, and I think we've attempted to continue to do that. And then the last thing I'll say is, this is an area generally where there is bipartisan political support strengthening our manufacturing sector. While I'm the policy guy, I can also say it polls quite well. No matter what you do, it polls quite well here. And I think that's important because getting bipartisan support around these initiatives is needed to get the resources required, but also to make sure that they're lasting. And just as one small example of that, we've had an unbelievable set of fights over budgets over the last several years. We are hopefully moving away from an era of governing by crisis, which is good for the country, good for the world. But even in those fights, one of the areas that we've been able to make progress is on advanced manufacturing research and development. So the overall non-defense discretionary budget has been very constrained, but we have been able to grow advanced manufacturing R&D, the actual appropriations that we're getting, by roughly 40%. And while I can't front run the specifics of our FY16 budget, I can say that I guarantee the request we will be making to the Hill will call for additional increases in advanced manufacturing R&D. It's continued to be one of our top priorities when we think about the federal government's overall R&D budget. So I'll pause there. I look forward to the discussion. I think this has been a huge success, but there's still a lot of work to do in terms of implementing, making these things lasting, and building a foundation for multiple years. Thank you.
Great. Thank you, Jason. Robin?
Well,
Can you turn your mic on? Just press it once.
thank you, Rob, and thank you, Jason. I think very apropos opening comments. I think as members of the Advanced Manufacturing Partnership 2.0, when we started looking at the space and saying, okay, what are the issues that we had to deal with, we clearly had the backdrop of the excellent work that was done by the AMP 1.0 team, and they had identified these three broad buckets around enabling innovation, securing the talent pipeline, and working on infrastructure problems like image, investments, etc., the scale up. So, Kristen will talk a little bit more about how we split ourselves up into various teams, and again, there was a lot of focus, as Jason mentioned, on action. The idea was our leaders from our companies and institutions were very focused that this just not be another report that be on the shelves, but we provide granular, distilled recommendations on specific areas. So one of the differences in the AMP 2.0 is that while at this level the recommendations are pretty holistic and comprehensive and perhaps even high level, the work that was done behind it and which is available in the appendices, and if you have time and energy or interest, I would recommend you definitely take a look at those 9 or 10 documents. The work was quite granular, especially in the area of manufacturing technologies. We went down, even had an argument whether we should develop technology roadmaps early on, but we actually went down gap analyses and really understanding each of these areas we picked and how we picked these areas. So there's actually a pretty good template that we developed sort of by piloting, doing and tweaking the process of identifying technology areas that were of broad interest to our manufacturing sector, not just a particular industry sector. So we'll talk a little bit more about the criteria and how we got there, but I think a key takeaway here was that the focus on intense action, but also at the end when we stepped back from all of it, we were also able to identify larger level gaps, and these recommendations can address both those granular gaps as well as the larger strategic gaps. So I'll close my opening remarks by saying that one of the key things we learned is that while there are lots of hands with good intentions, given the complexity of this topic, given the vastness of areas of technology and funding mechanisms and mechanisms of implementation, we felt there was a rather important need for a strategic stepping back and saying where the investments are going, how are these being implemented, which business models or implementation models are most effective in furthering the technology investments that are already being made, both in the private sector and public sector, but also where they're being implemented together, such as the NMMIs. So that is why there is a focus on developing a coherent innovation strategy in manufacturing, stepping back and looking at the best practices and sort of leveraging them across where it makes sense. Pass it on to Kristen for remarks.
Could I have that slide again? I think that's what that is.
Are you looking for the clicker?
Oh, no.
That's the microphone. Here we go.
Oh, you have it. Okay, great.
Pointed that way at the clock.
Okay. Well, right now it's not in show mode. Oh, okay. All right, great. So thank you also for making the time to talk with us. I think this team has really worked very hard over several years, and we're excited to have other people dive into this report because it conveys a lot of really thoughtful information, not just from the people who served on the Advanced Manufacturing Partnership, but also from all of the people who volunteered from industry, labor, academia to be part of the teams that really did the deep dives in the manufacturing technology areas as well as the other areas in which we worked. So I thought we would give you a high-level overview of how the partnership was run and then how that relates to the report itself. So when AMP was constructed, we were really developed a list of working items that we needed to do delivered to us through PCAST, through the President's Council of Advisors on Science and Technology. So when we were given that charge, we decided to address all the things that we were asked to look at by creating 5 what we called working teams. And the one that Ravi and I co-led along with a gentleman, Krishna Michelini from Honeywell, so we had 2 folks from industry, 1 person from academia, was working team 1. And there we focused on transformative manufacturing technologies. This was important because the first AMP report, which came out 2 years prior, had a list of 11 manufacturing technology areas, if you read that report, that they said seemed important to consider further for the country. But they were at various levels of granularity, specificity, maturity. So we thought this needed to be revisited, and maybe we would start with those 11, and maybe some of those would rise to the top, and maybe we would identify others, because manufacturing technology actually does move quickly, not only in this country, but in other countries. So we developed a process to start with those 11, and through surveys conducted within the wide range of companies, labor, academia, and interests really on the team, we developed criteria by which we would down select those. And those criteria are detailed in the report and the process by which we went through that exercise. But it was very eye-opening in terms of what manufacturing technology areas had a lot of industry pull, national security implications, cross-cutting potential, and ability to leverage existing U.S. strengths, whether that was in the technology or in the workforce. So those were our criteria, and with that process, we identified these 3 areas where we conducted deep dives with industry as well as a wide range of other manufacturing community representatives. So we studied these 3, they're listed here, and they have a complete series of, as Ravi mentioned, 10 annexes that are very, very detailed analyses of the vision for this in the US within a short time frame, 3 years, a longer time frame, 20 years. The gaps that were inhibiting implementation of the adoption of a lot of manufacturing innovation, and then the recommended actions that could be taken in those 3 very granular areas. And one of the areas we broke up further, the advanced materials manufacturing, is itself quite broad, and so we did deep dives into subsets of materials manufacturing, including advanced composites, biomanufacturing, and critical materials. These also, if you are following the history of manufacturing investment in the U.S., reflected a range of maturity in how the government was working with industry and academia to advance these. So the first one, advanced sensing controls and platforms for manufacturing. There is no announced Manufacturing Innovation Institute in this area. This is really bringing together a lot of new ideas to create this blueprint for manufacturing throughout the country. So this was the least well-developed idea, so we spent a lot of time thinking about the parts of that. The Visualization Informatics and Digital Manufacturing was timely because at the time the Digital Manufacturing Innovation Institute had been announced, so we wanted to take a look at that space and see what we could contribute to thinking about how to shape that. And then the Advanced Materials Manufacturing was one that wasn't an announced institute, but we thought industry and academia and labor together thought that was an area that was very ripe for further study and investment. The other working teams, which we can go into further as needed, were focused on the demand-driven workforce, so this is workforce training and education, analysis of how to actually develop this network of manufacturing innovation, including governance of these institutes, 5 of which have already been announced as investments. Issues on working team 4 of scale-up policy. So what are the policy recommendations required for manufacturing innovation to be scaled up? So not just startups and small companies, but really the scale-up of an innovation at any scale, and in particular the capital access and the information access that goes along with that. And then the 5th was on the image of manufacturing in the U.S. As you said, it is changing, but perhaps not rapidly enough. So those are the 5 working teams, and you'll see that work reflected in the 3 pillars of the report. Okay, so in enabling innovation, this was the work that our team did on the transformative technologies, as well as the analysis of the network and what is required to run a nationwide network with high impact, and also long-term industry engagement, which is a very important part of the partnership. The second pillar is securing the talent pipeline. So here you're going to find our recommendations and thoughts on the education and training, as well as the image and what needs to be done to revise the image. And there you will see that, as Jason mentioned, in real time, we have piloted several actual initiatives, including apprenticeship models through several of the companies that were part of AMP, and the community college networks that are a very vital part of this process. And then the third pillar is improving the business climate where the policy recommendations were put forth. So it's been a very exciting time to actually have this come together with a lot of people's effort to really look at this through a national lens. Okay, it's not a specific agency lens, nor a party lens, nor any one industry sector. So it's really been for the priority of the country in this area, and that's, I think, really brought out the best in people. And now the implementation plan is what we're eagerly seeking, right? So this was a set of recommendations that PCAST accepted and then sent to the president, and the president has accepted and then charged Jason and his colleagues with the implementation plan on the government side. But there's also a lot of implementation in the private sector through academia and industry, and we are doing our part through various mechanisms. So now we move forward, and we hope to keep the ball rolling, especially with engagement of folks like you. So thank you.
So great. Let me kick it off. I want to maybe start with a few questions, and then we'll open it up to folks. How do you? Yeah, I think one of the problems in Washington in general, which you can basically say is the problem for almost all things, are economists. And because they fundamentally don't think about or understand innovation, the vast majority of economists, and so they have this very sort of narrow view of the world. And I remember a piece we wrote a few years ago looking at the role of tax policy and innovation, and we ended up discovering this entire literature, which I didn't know existed, that showed that there were big, what economists call externalities from investments in advanced manufacturing. Historically, economists think there are only externalities from R&D. And it turns out that there are big externalities. An externality meaning if Dow invests in a particular sensor system, you actually get a lot of the benefit. You don't get all the benefits. Those spill over in a lot of different ways to your competitors and other people in the supply chain. And it turns out, at least according to the literature, that the spillovers from investment in advanced manufacturing technology are as big as the spillovers in investment in knowledge discovery. And so to me, that leads to a natural thing, is that tax policy should be more favorable to these kinds of investments. But I'd just be curious, and for both of you or Jason, you want to jump in, when you looked at these systems, what were the kinds of barriers you saw that would keep companies from adopting them at a more rapid pace that we would like? I mean, what are the things? Is it sort of chicken or egg problems? Is it complexity problems? Is it technology problems?
I'll take a first crack at this. I think it depends very much on both the industry sector you're talking about and also the scale of the industry. So for example, while a lot of us, participating in the team were from large companies, but we also have lived in very entrepreneurial small business units or elements of those companies. So we understand the small and medium sector, and we rely heavily on the network of small and medium folks in our supply chains to make things happen. So we focus a lot on small and medium enterprises, and talking to them, and it's a good example, you talked about sensors. If you look at the whole space of sensors and process control and platforms, just to explain that, sensors are the actual devices that sense what you're talking about. Having a sensor is good, but then you need to have a whole process control mechanism for controlling what you're trying to control with those sensors. And last but not least, these days, as you guys were discussing earlier on, the IT platforms that support these things, and the analytical capability, and especially in the new world between hybrid clouds, hybrid data platforms, private and public, and the security and infrastructure involvement, that is becoming more and more of a challenge. So to answer this question, if I'm a small and medium manufacturer, and in fact I serve on a couple of boards that are small companies, they don't even know what exists out there. So if I want to say I'm going to buy an equipment to make something, I'm very much at the mercy of the equipment supplier to say, here's my software and hardware that goes with this equipment, here's the control mechanisms, here's the historian, here's the process control algorithms. But it may not necessarily work for my application because by definition what I'm doing is innovative. So there isn't a place for me to go as a clearinghouse, a Wikipedia of sorts in this space to say, okay, am I using the right sensors? Am I using the right process control? There isn't a place for me to go on a risk-free basis and try. And if I make those mistakes, especially in the startup stage, picking the wrong one, it's going to be a very expensive mistake. Because first we'll lose time, but more important money, but more importantly time, because startups don't have time. So the idea around our technology platform was not just the technology piece, but the access to technology and expertise. and access to technology and expertise in an unbiased form. Because if I'm a seller of systems, I'm obviously going to tell them my system works the best. So which is why if you look at the recommendations that we talk about, the private-public manufacturing research and development infrastructure, the NMMIs have a role to play, which is the technology maturity, manufacturing readiness level between 4 and 7. And then we have a centers of excellence that comes to the earlier part of the equation. But what about those cutting edge technologies which kind of almost exist? I mean, a simple day-to-day fact that we face is when you look at your iPhone or your Android phone, you're not up to speed on all the apps that are there even. So the same situation on a mega scale exists for the manufacturing. So for that, as we look at it, the federal government has done some creative things. I mean, the Department of Commerce has, through the Manufacturing Extension Program, created a network now that touches hundreds of thousands of small medium enterprises. Except we have these channels, but we don't know what these channels are doing and how can they be leveraged. So one of our recommendations is to take mechanisms such as the MEP and really help scale them up by feeding them more products, technologies, and other things that they can go and become that one point of contact with the SME. The SME is here sitting working on a project, they call up the MEP contact officer or whoever it is, and the guy says, let me find out what I can do for you. Let me use my NMMI network, let me use my different networks that I have in the government systems, provide consultation. And actually another good example of that is in the Department of Energy heat and power space. They actually have these consulting models all the way from a professor with 2 grad students coming and doing an audit for your systems all the way to full consultation. So the models exist within our own infrastructure today, and one of the beautiful things we found is that if we take a step back strategically and look at marrying these models of what's working in one sector versus the other and just implement best practices, there is amazing amount of bang for the buck that we can get for the bucks that are already being spent. It's a long answer, but
No, that's very
articulates
helpful.
what we're trying to do.
Yeah, I would just add to that a little bit more. So we did look at scale-up policy, but we were specifically not tasked with looking at tax and regulatory policy. So, so that was not an area that we dove into, but in the scale-up policy, one of the common things that we found was the access to capital, because this is a long-term and typically capital-intensive investment, is a barrier. And then the access to information, as Ravi mentioned, is an equal barrier, especially for the smaller companies. So revising the offerings of not just the manufacturing extension partnerships, which are the statewide NIST-run effort, but also a range of private sector complements to that is important for the information. On the capital access side, we recommended several potential innovative things, including a manufacturing renaissance tax credit, right, that would actually provide that, as well as wider adoption of available tax credits that do exist for manufacturers, but they tend not to take advantage of because they weren't aware of them. So that's one mode. Another mode is to create a type of almost Kickstarter for manufacturer public-private fund. And so those models exist. They've been studied at MIT and other places, and they're proposed as one thing to consider in the report. So some of the existing tax credits that exist, small and medium enterprises are not eligible for because of their size and their tax burden. So there are mechanisms where small and mediums can work with larger companies who can assume the tax burden, right, and then become a partner in the development process. And that seems to be a very effective model in some manufacturing segments, but it's not widely used. So we brought those out. But I would say that within this room, although we didn't officially focus on tax and regulatory policy, we got a lot of feedback from the small and medium enterprises that all of this analysis and effort is very helpful and is very appreciated, but the uncertainty of the regulatory environment is one of the major things that keeps them from adopting new technology, even when they have the information to understand, for example, environmental regulations, which they're not opposed to, but the uncertainty with which they change and the timescales over which they change make it very difficult for them to adopt new technologies. So we didn't address it, but we do have a sentence in the report that urges that to be looked at in addition to what we've done.
Yes, your point about not being aware of certain things, I think, is an important one. Not to pick on economists all the time, but there is that great joke of the 2 economists walking down the street, and one economist, another guy walking down the street, and he sees a $100 bill, and Guy says, how come you didn't pick that up? He goes, well, if that $100 bill were really there, someone would have already picked it up. And the logic for economists is if these tax credits are there, they would have picked them up. I think a really good example of that is Patrick Von Bargen here. And years ago, we worked with Senator Bingaman's office when Patrick was there, and Senator Domenici's office, and we helped them put in place a collaborative R&D tax credit in the Energy Act of 2006, I believe. And what it is a tax credit that's a flat credit, 20% of all of your R&D, as opposed to the incremental one, which is much less generous, on energy R&D, particularly collaborative energy R&D. And it's a wonderful, wonderful tool, and yet hardly anybody knows about it. DOE doesn't advertise it on their website. When they work with companies at the labs, they don't put it in the brochure like, hey, you're working with us, you should take this credit because you just got a 20% discount on your CRADA. So your point, I think, is a good one, that there are these things out there that we need to do a better job of. There are already existing tools. Question on MEP, and my first job out of grad school was at NIST when MEP was not MEP, it was the Rockefeller State Technology Extension Program. I love MEP, and I think it's a great program, but one of their limitations is the funding model, because they have to, basically, for every dollar they spend, they got to get extra money. And I think that makes it harder for them to do system-wide investments. And I've always thought that one thing MEP should do, if they could get Congress to fund it, is to, why not have sort of a few people somewhere in MEP who are experts on number two, sensors and controls, and another group that's expert on number one. And in other words, then you would have, and maybe the way to do that is now with the NNMIs can play that role, but I think your point about having somebody in the system who knows that can play the coordinating role, and then maybe if it's the NNMIs, then the MEP network is feeding into that and helping.
Your point is well taken. I think that's why in our report we recommend a couple of things. One is, if you take, for example, the ASCPM, or you take, for example, the other one, VIDM, any of these technology areas, you're not going to solve all problems for all people, so you have to pick a space. So, for example, the thought would be, let's say if you're going to do advanced sensors and technology for a particular industry, and let's say we pick the southeastern part of the U.S., somewhere in the Tennessee, Georgia, that whole area, and we say, we could create a test bed for the dominant industry here, or a machining industry somewhere else. Create a test bed where small and medium manufacturers can come in, test their live scenario out. And this is funded, let's say 50% by the government. State governments obviously have an incentive to have this thing successful. They put some money in, some of the large corporations who have wares to sell, and maybe even smaller consulting companies and innovative companies that are looking to get into this funded. And then finally, the user fees pay for the small, medium guy who wants to come and test it out at low-risk basis without putting his production at risk. You do 3 or 4 of these and they become successful, it becomes a lot more easier to fund. And the parallel is the combined heat and power program. If you go to their website, you will see combined heat and power for the dairy industry, for the hospitals. And they're all done in different regions, but they leverage best practices. So if a hospital in California is doing something, they can easily translate that best practice to New England. So we see there are models that exist. It's a question of somebody to step back and say, these things are best in class, let's put it together.
And I think I would just add to that, that we found that information transfer and use of mechanisms like the MEPs, you're right that there's expertise that might be not geographically well distributed, but that for especially the small companies, having that expertise and input regionally close was important for several reasons, right? They need that ecosystem to be around them. They also, even though you can communicate online, with manufacturing, a lot of things really need to be seen and touched, right? So we did a pilot study. We actually did a study on this information access, using not the MEPs as the mechanism, but actually private sector counterparts to the MEPs in one region around one manufacturing process and product. So you can read that, and the full report in a didactic form is included. So I think that it's a very interesting example of why you actually need things like the MEPs, geographically distributed pockets of experts where you can bring in someone from across the country, but you need a standing body there to support the information.
Okay. Jason?
A couple of things on this topic. I think stepping back, this whole area of the supply chain, small and medium manufacturers, is a real challenge in the United States. It's something that the AMP highlighted. It's something that other manufacturing reports have highlighted. And if you think about the path of U.S. manufacturing over the last 15 years, last decade, a lot of these companies were in survival mode, right? They were in pure survival mode. And as a result of that, that meant a lot of underinvestment happening in the sector. So as you have factories closing, as you were laying workers off, your focus wasn't, let's spend time on finding these technologies, and part of it is a search cost, right? High search costs for small manufacturers, which Ravi and Kristen talked about. So you're in survival mode for 10 years. We lost a lot of them. And if you're investing in something with a 3-year, 5-year, 7-year payback, you might be gone in 6 months. And that, I think, was a real challenge. And in 2009, 2010, a lot of the things we did from a policy perspective are, let's prevent a downward spiral, right? Let's prevent a downward spiral in the supply chain. Now we're in a, let's build out these capabilities mode. And if we are not successful in building out those capabilities, I think there's going to be an enormous missed opportunity, because the broader economics are generally in the United States' favor right now. Some of the, and I think what you're hearing from Ravi and Kristen and what the AMP made clear is, it's really a broad set of things that need to happen. And I would just highlight a couple things. One, just to pile on a plug for MEP, I think it is a fantastic program. I think they are very much taking these recommendations to heart and are working to do things like embedding technology-specific expertise in specific places that they can then leverage across the network. Really focus on solving some of these information problems in different ways, and transforming their service, the services that they offer, to address some of it. The second thing I would say is, one of the places that one of the sets of organizations that can solve this is big companies that are customers for a lot of these organizations, both their first tier and second tier suppliers. And you see some companies do this in interesting ways. One small example is Honda will actually embed its own engineers into its suppliers. And that is because the Honda engineers are seeing a whole set of technologies that their small suppliers aren't. It makes them more efficient in the near term. It helps them invest in product development, product innovation over time. And so really systematically thinking about ways to encourage big customers, if you will, to invest in their supply chains is particularly important, because over the last 15 years, you've seen more and more get placed on the supply chain as companies have become less vertically integrated in a lot of different ways. The last thing I would say, to your intro point on tax, the president's at the Business Roundtable today talking to a number of primarily CEOs of large companies. One of the things he's going to raise is the importance of getting business tax reform done in the next Congress. Something that everybody kind of talks about over and over and over, but it's not getting done. So we actually need to focus on it getting done. And despite all the noise, I think the substantive differences aren't as big as the noise suggests. So if you look at proposals from Republicans and proposals from Democrats and proposals from the administration, you can see what the negotiating space is. They fundamentally have the same structure, but have areas where people are going to actually have to come together to get it done. I do think one of your points is important, which is, if you think about manufacturing activity as something with positive spillover benefits, you should care about production, and the domestic production deduction, which we in our proposal maintain, enables you to bring down both the statutory and effective tax rate for manufacturing. And so a simple version of corporate tax that gets rid of all credits and deductions eliminates that domestic production deduction, and then no longer differentiates production activity from other economic activity. So I think that's a really important piece. It allows you to bring down the effective rates on our plan. The the statutory rate comes down from 35 to 28, and it's effectively below 25 for manufacturers. So maintaining some version of that, I think, is really critical as this moves forward. But either way, it needs to be, a top agenda item to get done.
Just to put in our plug for that, there's Joe Kennedy wrote a sort of magnum opus on corporate tax reform recently as an ITIF report, which you can look at. One of the concerns that we have, Jason, just to your point about, it's not just the manufacturing, the production deduction that's potentially on the chopping block. It's things like the R&D tax credit. It's what's called MACRS, Modified Accelerated Credit Recovery System, which lets these companies write these investments off sooner. And so our worry is that sort of in the third time I'm going to critique economists. The economist view of the world is that the tax code shouldn't interfere with the market and these decisions. And yet we all know there are big spillovers, there are big externalities, and that's what the domestic production deduction is trying to get at. One last question, I just want to open it up. I didn't see my favorite technology on the list, but maybe that's because it's sort of embedded here, and it's not the iPhone, by the way. It is actually my favorite technology now, so I just have one. It's robotics, and you see it sort of in pieces there, like you have sensors and control systems, which are obviously in vision, which are all in robotics. But did you not? How did you think about robotics?
It was on the original list of 11, and I think there was a significant National Robotics Initiative launched. So we were trying to kind of sync up with them and figure out but we figured with the resources that we had, and with that effort going on, it would be just redundant.
Okay.
Well, and I'll just expand on that. So it was actually fourth on the list. In terms of rank order, advanced materials manufacturing was first, and robotics, industrial robotics specifically. So robotics for manufacturing, less than manufacturing of robots.
Sure.
So that was fourth on the list, and we did in those 4 areas, we spent a month writing what we call framework documents. So if we were to do a deep dive in this area, where's the landscape? What are the current efforts within the country already? And industrial robotics was first really well covered by the robotics initiative that's going on now, the challenges, the network, the information transfer, and so forth. And second, the companies that you think about making cool robots, they were not interested in giving a lot of feedback to industrial robotics. They say, well, we don't make robots for manufacturing. We don't make assembly line robots. We make very cool Roombas or something like this. So there wasn't that convergence of the range of the supply chain wanting to focus on this, nor really the need, because the robotics initiative is so well organized.
Okay.
But to your point, I think it is inbuilt in both the VIDM space as well as the ASVPM space, because the informatics and all the information, in fact, using some of these optimization mechanisms, there was actually a case study that we looked at where one of the European manufacturers is looking at not just the consumption of energy for a particular activity, but optimizing even the movements of the robots as they work to reduce system energy reduction by almost 25 to 40% in the production of a particular equipment. So that kind of we actually submitted a white paper or a proposal for a clean energy manufacturing innovation institute, which embodied this concept of looking even large industrial usage and optimizing energy and other resources using these mechanisms.
And maybe just to amplify that point, so when Ravi says that we submitted a white paper, so the various agencies that are individually funding the manufacturing institutes right now have been putting out requests for information, and anyone can respond to those, any individual organization. So AMP responded to a couple of those as AMP building on some of the work. But that was a very useful process of getting input from industry and academia on what the priorities and challenges were. And hopefully, if there's more than the 8 manufacturing institutes, that process of information exchange would go on. But because you need that private sector input and you need it continuously, you don't want it to be dependent on there being new institutes rolled out periodically and so forth. So we did recommend that there be an advanced manufacturing advisory consortium. That was our second recommendation. And that was to provide a channel for this private sector input, because that detailed input was an important part of this effort, and even institute topic selection benefits from that, but other things too as well. So we understand that plan is moving forward. That there will be a consortium created for that private sector input. The other is, to your point, my favorite one wasn't chosen. You weren't alone, and we heard from a lot of people who felt that their favorite one wasn't chosen, as you can imagine. So this was really because we had a year to work on this, and we wanted to do a credible, thorough job, so we couldn't cover everyone's favorite manufacturing topic. But our first recommendation was that there needs to be a national manufacturing technology strategy. There is already a national manufacturing strategy, which gave rise to the National Program Office, the National Network, and so forth. But which technologies are going to be prioritized? And that's important as a signal to industry for lots of reasons. It's also important to coordinate the federal resources and the state resources against which technologies to invest in, how to capitalize on regional strengths, and so forth. So that was actually our very first recommendation, is that the government establish a national strategy for which technologies are going to be of high priority. Other countries do that out of necessity because they're smaller, but we really need to do it for better coordination of all the resources and information that we have. And we understand that technology strategy development effort at a national level to cover a wider range of topics, but perhaps only choose, 3. I don't know what that outcome will be, but that is also moving forward through the auspices of the Office of Science and Technology Policy.
Okay, great. So let me open it up to folks, comments or questions, and I guess there's a mic here also.
My question has to do with building political momentum behind your good work, with 2 questions really. One, to what extent has the National Association of Manufacturers been involved, interested in your work, the priority they give your work, and maybe a comment about the Chamber of Commerce as well. And then the second question is, are you aware of studies, economic studies being done that are trying to estimate the economic benefits of innovative advanced manufacturing in terms of jobs created, wages generated, wealth created, that kind of thing?
I'll take the second question first. I think when we started this whole AMP process, there was a general understanding that there's clearly, you wouldn't do this if there was not a net positive impact on GDP and job creation. But we decided to stay away from the actual calculation of those, or even an effort to doing those, because of the uncertainty. And at that point, we really didn't know which way we were going to head towards. But you can hypothesize relatively easily. In fact, in the ASCPM and other documents we've looked at, what kind of value creation, what kind of cost reductions can be done in the various value chains that we talk about, especially in the VIDM space. As you look at optimizing across the entire supply chain, changes to product design, all the way feeding back across the supply chain to each of the manufacturers. There is tremendous potential for value creation, as well as for flexibility and agility in the value chains, especially when there are external shocks that this value chain doesn't expect. So in essence, there is a strong conviction that there is significant positive impact, but if we actually put a number around it, no, but there are some indications of what has been done. And there's obviously a plethora of references and documents, and the Mittelstand in Germany and other places that have studied some of these effects, so they are pretty clear. The first one on National Association of Manufacturing, I know during the process when we started off, and maybe Jason can speak to this more, there were multiple outreach efforts and many contact points. So a lot of people are aware, but as to whether they actively participated, we clearly had the labor unions actively participate in this. So.
Well, and also we held a series of regional meetings to help the states figure out manufacturing plans, and there were, I think,
3 workshops.
No, it was more than that. I think it was probably 5, and they're listed in the report all across the country. But one of them occurred in Michigan in June, and this was a very large meeting that included all of the major manufacturers and the Big M meeting. And so that did include the National Association of Manufacturers as a major participant in that. But one of the organizations that's related that we worked with a bit more closely on the workforce development side is Manufacturing Institute, the Manufacturing Institute. So the Manufacturing Institute is taking all of the workforce training and education and apprenticeship model tools that we developed over the course of the year and implemented in a couple of states. they are actually curating and making those documents available to any association related to manufacturing that wants them. So that has been a closer partner on the workforce effort. And then Department of Commerce has been has really been a champion of this entire effort. And Secretary Pritzker was very involved and led the steering committee meetings on this. So the chambers of commerce will, take their cue, and I think the regional meetings went a long way to making that happen. I can speak for what happened in Massachusetts. We had a regional meeting in Massachusetts, and we had a lot of involvement of the state and local governments who were interested in this information and how to make it relevant to that region.
So, I know it's hard for Jason to jump in on this one, so I'll jump in. Look, let's be honest. I think part of the problem is that NAM is not focused on these questions in a serious way. And if you compare them, say, to the Canadian counterpart, which is, I'm blanking on the name of the organization, the Canadian Association of Industry and something or other, they are one of the leading proponents in Canadian politics of an advanced manufacturing strategy for the Canadian government. They actually care about it. They spend their political capital to lobby for it. And frankly, NAM has not done that in any serious way in the U.S. They've been much more passive and arguing largely for any sort of business climate agenda. And I think that we see it in the results. Canadians invest 10 times more than we do as a share of GDP in advanced manufacturing technology support. The Germans invest 20 times more, the Japanese invest 40 times more. So I was pleased to see that NAM initially, even though initially they opposed the NNMI, which I found was striking, the National Network of Manufacturing Innovation, that NAM initially opposed it, but have come around to support it. And I think, to their credit, I think their support of it has helped with what's called the RAMI bill in the Congress. So I give NAM credit for coming around to this, but I just would hope and wish NAM would be more active on these kinds of issues, because there's a study that they've done that we've sort of tweaked the data on, and there's this notion that if we just lower costs for manufacturers even more in the U.S., that we'll be successful. And the reality is we're getting outcompeted by manufacturing countries that have significantly higher costs. I mean, our manufacturing costs, fully loaded labor costs, energy, regulatory costs, all of that fully loaded, are about at the level of Korea. South Korea. And we're way below Germany, we're below France, we're below the UK. Now, it's not to say that there aren't things we ought to do in that space. Surely there are. Energy is a great one with fracking and others, and getting smart regulation. But the idea that we're going to win just by lowering our wage costs another 50 cents, I think, is just foolish. Anyway, sorry for the rant, but I just couldn't resist on that one. So, other comments or questions? If you want to just wait for the mic.
I'm Bob Hershey. I'm a consulting engineer. What has been done to try and gather together money by consensus for some of these efforts in some of the areas, particularly using the internet to communicate with people?
Well, one version of an answer to that is that these manufacturing institutes that have been stood up are public-private partnerships with a one-to-one match from the federal government invests money, and then industry comes forward with cash and in-kind, cost sharing. Right, so that's a very considerable investment from the private sector. It's definitely pooled resources because each institute is on the order of $70 million of federal investment and $70 million of cost share from non-federal sources. It could be the state, but it's more typically large contributions from many, many companies. So that's a model that I think that the federal government has very smartly put a lot of pressure on industry to pick up the dime 5 years down the road. So the model is that these institutes should prove their value with the catalyzing funds from the federal government in 5 years, and should be self-sustaining because they're so beneficial to industry that they'll pay to keep them running thereafter, as long as needed. So that's one example of the fundraising that's gone on from private sector.
And I think which also speaks to the point we talked earlier about, is having a broad strategy and having some selected areas of emphasis, because in the private sector and in the academic sector, you develop talent, you develop people, you develop budgets, and allocate these things over a long period of time. So knowing that these are the prioritized areas gives everybody a sense of continuity, purpose, and a direction in which to head, as opposed to having one area being hot one day, another one being hot the next day. So again, the purpose of having the Advanced Manufacturing Advisory Council, the strategy piece, and looking at the continuum of different mechanisms, all speak to having a long sense of purpose, a vision, and driving that forward in collaboration with all partners at the table.
Yes, sir, in the back there.
Hi, I'm Harry Mayfield with Lewisburg Associates. We're a consulting and lobbying firm that works with research universities here in DC. So I kind of have a devil's advocate question. One of the recommendations is that to create new centers of excellence and test beds for manufacturing. So how would you all respond to folks who say that we've spent a lot of federal dollars already covering this space with current and future NMI centers, NIST centers of excellence, the ANTEC consortium program out of NIST, MEP, other efforts at NSF, DoD?
So that's a very that's a question that we were asked often, right? So you are among many devil's advocates. We suggested this mechanism, but we didn't suggest or even think that it required new funds. So the idea was to use existing programs, but focus their efforts on materials centers for excellence at the lower technology readiness levels and the lower manufacturing readiness levels, right? So great examples already exist within the federal government, such as the NSF's engineering research centers, right? But although this is not our call, you could certainly earmark a certain number of those to be targeted towards manufacturing innovation, right? So that would be an example on the lower MRL, TRL side. On the manufacturing technology test bed, the thinking is similar to the Institute. So this is higher MRL, right? So that there would be some federal catalyzing funds, and perhaps this could come from existing mechanisms, but this would be so advantageous to industry that the industry would support this over time once the space was available for that. So those two mechanisms don't call for new federal investment, but better let's say, prioritized use of current federal investment.
And I think there is nothing to state that these terminologies that we have developed all have definitions and functionality behind them. So there is nothing to state that an existing MEP or an MTAC, one of these other ideas that you talked about, which is being piloted as well. In fact, the MTAC and the testbed ideas are very similar. It doesn't mean that you can't repurpose an MTAC and make it that. So the functionality is what we really focused on. These nomenclature we had to come up with because we didn't want to be jumping on a particular nomenclature that has a particular meaning that we are not aware of. So it's clearly possible, as Kristen pointed out, to repurpose with a focus on achieving the end objective. What the name is kind of not that relevant.
One other answer to that is study we just did a year and a half ago. We actually rank as a country 22nd in the OECD in university funding of R&D. So the idea that we're putting enough money into these systems, and we're clearly not. There are 21 other countries that put more money into their university R&D systems as a share of their economy than we do. So I think it's hard politically to argue for more money in the budget climate, but I think that's an important point. One question I had for you is how much of this, when you were thinking about this, how much did China sort of inform your thinking? Because part of this obviously is how do we regain a competitive advantage over China? Clearly, technologies that enable customization are one of the lower production runs, shorter production runs are better for us. But there are other things there. And obviously, China's putting their own resources into advanced manufacturing technology.
Yeah, and I'll let Kristen talk to it as well. Especially coming from the industry, and that's coming from the chemicals, materials, and bio, the general sciences industry, you're never ever not thinking about China. So it's clearly. But also on the other hand, you have to understand that our understanding of how China operates, and especially what's going on now with respect to their recalibrating their economic system of calibrating debt versus equity and how they allocate the capital to the various industries. Having said that, our focus has really been on how do we make ourselves more competitive and leverage the advantages we have. So, for example, the ASEPM or the VIDM spaces speak exactly to that point. Because one of the advantages of the US system, again, this goes back to leveraging our strength, is our systems thinking. Our education system, our grad school work, our engineering cultures, the way we develop projects and how cross-functional we are in our approach. We really excel at and encourage cross-functional systems thinking in the very beginnings of every organization. My kids are doing high school projects and I'm stunned at how much cross-functional thinking they're doing at 8th and 9th grades. So if you think about ASEPM and how we're talking about systems, hardware, software, the platforms and the IT infrastructure all working together, you talk about the visualization, digital manufacturing, the same concept, and you talk about the material space as well, thinking systematically. I think we have the ability to leapfrog where others are with that kind of an approach. So it is more in fact, one of the points that we make in our report is about when you design plants and equipment, we have a culture around safety. How do you design equipment for safety? How do you design equipment for energy efficiency? That design needs to move on to how do you design a system with sensing and process control in mind a priori. That culture isn't as strong, but we need to get to that point, and that gives us further competitive advantage.
But I think to add on to that, so in certain industry sectors and manufacturing sectors, there is a lot of perceived competitive advantage for rapid scale up, rapid scale down, like you said. So biomanufacturing is one of those areas. We did a deep dive in that area focusing on biological therapeutics. The biomanufacturing is also a broad term. So in that area, a lot of the perceived advantage against other countries, including China, would be the ability to rapidly scale up a production process, rapidly scale it down, but also have attendant automated processes related to safety, right? Identification of contaminants and so forth. And that was a pre-competitive space where there was a lot of agreement around lots of companies being able to work together on that. Because that can be a distinction, right, in terms of things that can be done here. I think the other distinction or the way that countries like China are on our mind, beyond the investment and beyond maybe disparate wage structures and an ability to have a large pool of workers at certain levels, is the difference in the education. So it was very clear that chemical engineering departments in the United States don't now train their students in the kinds of chemical engineering that gives rise to manufacturing, whether it's rapid scale up and scale down, or whether it's even oil refining. Right? That's not how we're training our students now at the top places for the highest degrees that go on to develop some of these innovations, nor is it how we train at the community college level in terms of credentials. So there was, from several sectors, a real willingness, but also a real need to train the domestic workforce in manufacturing relevant skills, right? And there needs to be a student demand for that and a parent demand for that, so that goes back to the image of manufacturing as well.
Can I
Go ahead, Dixon. Yeah.
let me add a couple.
Yeah.
I think Kristen's last point is a really important one around education throughout the system, where, I mean, the most granular and obvious example, right, is that people that shop is no longer exists in many places, and that carries itself all the way through PhD training, where the physical making of things has in too many places been taken out of education and training, and we need to put it back in. And I think a lot of our top engineering schools are looking very closely at that problem and have started moving in the other direction, which I think is important. But we have a long way to go. Definitely in the community college system and the high school system, we need to do that as well. To the broader question of China, let me just make 2 points. One, I think part of what we need to do as we think about rebuilding our manufacturing infrastructure is thinking about concentration of capabilities and doing it in a way that has roots. It's one of the ideas behind the institutes, is building these concentrations of capabilities in places that makes it more attractive for investment to come here versus go elsewhere. The second thing is leveraging our unique strength in entrepreneurship. Manufacturing is a space where over the last several years the cost of building something has come down dramatically, whether it be digital design, additive manufacturing, all of these different technologies integrated really allow you to create a product faster and at lower cost than you were able to before a prototype. We really need to start thinking more directly about the things that we're doing in creating entrepreneurial ecosystems to encourage those ecosystems to focus on physical goods. But doing that alone without the scale up behind it is a problem. I think one of the most compelling facts that went into some of the scale up work at the beginning, which came out of a study from MIT, was when you look at a group, I think the number was 187 if I remember correctly, 187 companies that were started out of MIT in physical products. About a third of them were in life sciences, so throw those out for a bunch of reasons. The other 2/3 built their first commercial facility in Asia. And if you're building your first commercial facility in Asia with the most innovative technologies across a wide range of industries, that concentration of capabilities is going to build up elsewhere. So we need to build institutions that encourage concentration of capabilities, but part of that is the scaling of first-of-a-kind technologies. You want that first plant here. We need the right incentives to do it here. And some of that's at a state and local level as well. Right? State and local governments that focus on fighting over moving plants back and forth across state borders is an incredibly inefficient national use of resources. If those state and local governments were focused on getting people who are thinking about the next technology to build their first plant in that state, that would have enormous spillover benefits for that area, but also for the country. And it would be an efficient national use of those resources. So when we think about the broad competitiveness question, whether it be China or elsewhere, how do you develop this concentration of capabilities, leveraging our natural strength in entrepreneurship, and making sure that the scaling of first-of-a-kind technologies, when it's being invented here, we're making it here, is really critical to seeding growth for the next 10 to 20 years.
That's great. Bill.
There you go.
Thanks. This is really a question for Jason, and it's really on the implementation of recommendations here. And a lot of cooking is still going on in the kitchen, obviously, in the administration. But, I just wanted to, push you on what you can say at this point about what the administration is thinking on implementation of some of these major recommendations. So in the area of technology development, we've heard about strategies, we've heard about R&D coordination, we've heard about, bringing in a new kind of advisory mechanism that brings in private sector thinking and university expert thinking into the process. How are those pieces kind of shaping up? What are you all thinking about workforce? A number of these things have been referenced, but I just wanted to see if we could get some of this stuff on the table so folks emerge here with a picture of what's going to be happening maybe in the next 6 months. And I recognize you can't talk about some.
Just give us the State of the Union, Jason.
Yeah.
Would you mind?
So the State of the Union is strong. Let me share what I can share here and provide a little bit more color on things that Kristen and Ravi mentioned. So on the technology front, there are two general mechanisms that we're putting in place. And one of the questions, as one should ask, approaching the 7th year of an administration, is when I put these in place, they need to last beyond the next 24 months. So the first is creating the interface for advanced manufacturing technology with the non-federal space. So principally experts from academia and industry, and that's going to be an advanced manufacturing consortia that is going to be likely co-led by NSF and NIST. So you're bringing the industry piece and the university piece together. The second is the internal coordination mechanism, which I think we've built the infrastructure for and now need to turbocharge. And the way we do that, this is a natural area for OSTP leadership on technology coordination, but it's going to involve my office as well, is we need to do two things. One is enhanced information sharing across federal agencies on priorities, and then joint priority setting as we think about investment. So the way we're building that is through the NSTC, which is National Science Technology Council, which is led by OSTP, and we're building that mechanism right now. So that's our internal coordination mechanism with the advisory committee mechanism. I think on the specifics of the definitely under the 3 priority technology areas, there's work underway on each of them, some of which I can't fully share, but when we talk about materials manufacturing centers of excellence, there are tangible plans being developed for us to move some of those pieces forward in the near term. On the workforce piece, I think this is an area where people, it's a problem, it's a challenge, and our workforce system in this country is enormously disaggregated. So there's an unfortunate view that nothing is happening, but I think there's an immense amount of work underway. One of the interesting things, we spent $2 billion over the last couple of years in roughly $500 million rounds to invest in capabilities at community colleges to train people for job-ready skills. About half of that money went to advanced manufacturing. So 10% of the private sector workforce, but 50% of the money we spent in upgrading community college capabilities was for advanced manufacturing. That partially shows the demand, but it also shows our commitment in that space. We have a lot more work there, but we have, as we're thinking about workforce more broadly, I think building specific pillars around apprenticeship and making sure that the investments that we've made in community colleges are lasting, scaled, and replicable. On the last piece, on the business development and scale up, I think there's a lot of work underway in MEP. That's only one part of the solution, but I think you're going to see a lot from Phil Singerman and the MEP team in the months ahead. Really they're very much building MEP for the future, and I think a lot of that came out of the AMP work. In addition, we will have new proposals that directly address scale up that will be in the FY16 budget that came out of this, some of which will require congressional legislation. So we'll need a big push to get some of those things done, and whether or not we get them done in the next 12 months, the next 24 months, to the extent that it requires legislation, I think we feel this is important that we really build a foundation for support in these spaces, because while things are a little contentious at the moment in Congress, and we'll see what happens as the next Congress opens in January, these are good ideas that should have bipartisan support. So we're going to look for moments of opportunity to push them forward. More broadly, in terms of implementation accountability, the last recommendation from the AMP was OSTP and NEC at the White House providing basically reports to the president, starting with an implementation plan, which will be due very soon before the holidays, which we are going to get to him in terms of where we're at and how we're tackling each of the items on the list. Some of them we still have some work to do. I think some of them we have very clear plans, but we are taking seriously, and the president has tasked us with taking seriously implementation and making sure that we're holding ourselves accountable.
I think the one point to add over here is that, and I think it was well stated by one of the leaders, is that you can't do a little bit of this and a little bit of that. This is really a holistic effort. You have to look at the what and the how all together. Push the strategy, push the implementation plans, develop the talent pipeline, and make sure that the scale-up infrastructure exists in supporting these things. And I think innovation is not just required in the manufacturing sector. Innovation is required in this space as to how to get things done. I think I'm encouraged by the fact that we've been innovative in the approaches that we're taking to put these recommendations into place. There's obviously FACA constraints, there's departmental constraints, and I think personally for me it has also been interesting and very encouraging to see the interdepartmental sort of dialogue and discussion on some of these technology areas elevate to the next level in terms of coordinating future investments, because every agency is constrained by their mission, but they're finding ways to work across. So that's been some innovation there as well, I think.
Yes, sir.
Jean-François Breton with the French Treasury. Two questions really. Jason, I think, mentioned Honda as an example of best practices in sharing with their suppliers. I remember a few years back in Detroit listening to second-tier suppliers who complained bitterly about the pressure that was put on them by both actually Big Three and first year on prices and nothing else, nothing about quality and so on. So do you think that after the crisis that behavior has changed from the Big Three or their first year suppliers? And the second question is, on all of these issues of workforce education, sharing, image of industry, how much do you think you can leverage foreign investors, for example, Japanese or German manufacturers, who I think are really very well positioned to work on all of these issues?
So on your first question, obviously the Big Three were in survival mode for a long time. And getting out of survival mode is important in solving these problems. I think there's some good examples of Ford taking steps to really unlock innovation, both within its supply chain as well within the broader community, opening up its labs to its own engineers, other people, etc. But I think more broadly in the United States, this is within a lot of large corporations, a cultural shift that will be required and is still evolving. Just one small example of this, we launched this effort called Supplier Pay. And this is because the focus on piece price sometimes extends to payment terms as well. So, large company with 4% cost of debt, small company with 12% cost of debt, and in the deal you're pushing on payment terms because it looks good for your cash flow, and the person in the finance organization is getting compensated on that. But that means you have higher costs in the supply chain because you're moving working capital costs from 4% to 12%, and that's really bad for the system. So I think you have a broad set of supply chain issues that we'll need to continue to work through, and I think there are a number of strong examples of leadership in this space, but we have more work to do. The second point on foreign investors, I would say two things. One, Siemens was a big partner in this effort overall, and a leader in a number of different areas, apprenticeship in particular, which is not surprising given that if you look at relative metrics, the United States dramatically underinvests in apprenticeship, and Germany is a leader in it. However, one of the things that Eric Spiegel, who is the US CEO of Siemens, said that I thought was very interesting, when they were building their apprenticeship program in North Carolina, they found it enormously both time-consuming and difficult, despite their company's long-standing set of apprenticeship programs in Germany. So translating all of their expertise in building a workforce apprenticeship program in the United States was not easy for a company that is one of the world's leaders in apprenticeship programs. So there's no doubt that we've looked to examples of companies headquartered outside of the United States, many of whom have tens of thousands of employees within the United States. The second thing on this point I would say is we've been very active over the last several years trying to increase foreign direct investment into the U.S. In part because I think the economics are very favorable to the U.S., in part because I think there was a misperception for a long time that the U.S. wasn't welcome to foreign investment, or wasn't welcoming to foreign investment. And the president launched what's called our Select USA program to directly try and encourage more companies from around the world to come here, open up shop here, grow here, invest here, hire here. And I think that's been successful. It's started to change perspectives. And back to Rob's bludgeoning of economists, one of the interesting things that you find in this space when you talk to large multinational companies, and I remember this from when I was working for a lot of those companies making investment decisions in multiple countries, you don't have the time or the capability to evaluate every potential location in the world for every potential investment that you're going to make. So the way location decisions tend to get made is someone creates a short list that is very, very loosely based upon a small set of economic factors, and you evaluate that short list. And for a long time, the United States was not on that short list. And part of that was a perception issue that I think we're changing, but we still have more work to do.
Great. So let me just close by, first of all, a quick commercial and then a thanks. On the commercial side, we are hosting another conference, or a bigger conference, tomorrow at the Newseum, 1 to 5, if you're interested in it, on policy framework for the Internet of Things. We have 3 U.S. senators, and the head of the Internet of Things Task Force for the House will be there, as well as a number of industrial leaders and others. But it will include a discussion of the industrial Internet of Things. We're talking about what the right name for that is, but whatever the name is, it'll include a discussion of what's the right policy framework for moving forward in this space, including in the industry space. So that's tomorrow. Secondly, we have a couple of job openings. If you know young people who are interested in some jobs at a think tank, and look at our website. That just went up yesterday. And then lastly, I want to thank Kristen and Ravi for their how much did you get paid for this, by the way?
Negative.
Negative pay. You probably had to pay for your own lunch. I know how these government things work. So obviously, I want to thank you for your time and commitment and hard work to really make this a reality. Because without that, I know Jason couldn't do the work he's doing. And then obviously, Jason, thank you for all you're doing in the administration and really trying to put advanced manufacturing up a much higher level where it belongs. So with that, thank you all for coming, and then please join me in thanking a great panel.